Hi there, and welcome to Function Operations. We're going to look at all the different ways that we can combine functions. Some of these will be fairly straightforward, and at the end we're going to introduce most likely something that is new for you. So the biggest thing to remember that when we combine functions, that we need to be careful about the domain, because when we combine these functions, the domain has to work for both of them. So that is something to keep in mind. But in order to keep things kind of nice and easy for us, because I just want to focus on how we combine, is we're going to take a look at two functions that are going to be relatively straightforward because I created linear examples. So good news is with linear functions, I know that their domain is all real numbers. So I can combine them and I don't really need to worry about anything at all because their domains work for everything. So that first little point won't matter just because I want to practice. So we're going to try the first one, which is addition. So you're going to see a function notation. So I wanted to be sure you were familiar with that. So when we're combining these, all you're going to do is take f, so that's the one up there, and then in this particular case, we're going to do addition with these functions. And now it's just going to be a matter of combining like terms to get that final product. So 4x and 3x gives me 7x, and the minus 5 is just going to get carried down because, well, it doesn't really get combined with anything. All right, final answer. So here's the good news. Instead of having to plug something like -6 into both functions and then combining the answers, all I have to do is use this new created equation above. So I'm going to do 7. And then wherever I see an x, I'm going to plug in -6. And now it's a whole lot nicer for me to try to do. So I've got -42, and then I'm going to take away 5, so -47 is the final answer. That's a whole lot faster than trying to plug it into both and then combine my answers. That's kind of why we like combined functions. Addition's pretty straightforward, so let's try subtraction. Go ahead and try this on your paper and then hit play. All right, welcome back. So on here we have f of x. So again, we have how it's written. So basically I'm subtracting these two functions. So in this case, I've got 3x minus 5. And then I'm going to take away the other one, which is g of x, which was 4x. And again, I just need to be sure that I simplify as much as I possibly can. So I've got 3x minus 4x. So I have -x and then the minus 5 underneath. Final answer. Okay, now I just got to be sure that I plug in wherever I see an x. So I've got negative something that looks like this. So I'm just going to plug in +4. Goes pretty quick once you get comfortable, but it is a little goofy at first, I will say that. So -9. Again, a lot faster than plugging 4 into two different places and trying to simplify. You're much less likely to get mistakes. The one thing I will say to be cautious, I'm going to put a little star right here because I want to show you what happens when we go the other way around. Let's say I asked you to do g of x minus f of x. This is something you may want to do in your margin because this is usually what gets the most confused. So what would happen is I would have to take g of x, which was 4x, and then I would have to subtract all of f of x. So hopefully you start to see why this one we have to be very, very careful. Sorry, let's make that black. Because I'd have to take this negative and distribute. And then I would have to simplify all my like terms. So on this one, this would be regular x, and then you see negative and a negative, +5. So be really, really careful about that negative when we subtract. It loves to be very, very sneaky. So I would drop that in the margin. All right, we're going to try multiplication and we're going to try division. So again, here's my f and g. So we're going to try to multiply and we're going to try to divide. So, okay. So I've got g of x and f of x. So I've got 4x. And I'm going to write these kind of side by side, kind of like this. So 3x minus 5 looks something kind of like that. Okay, I'm going to need to distribute. So I've got 12, 4 times 3, x times x squared. Again, a number times itself. So things like 3 times 3 is 3 squared. So kind of the same thing with this one. And then I've got 4x times minus 5. So I've got negative 20 and x. All right, now I'm just going to plug in on the last one. So wherever I see an x, I'm going to plug in positive 2. So I'm going to take 12. Looks like I'm going to have to square that. Minus 20. Wherever I see an x, I'm going to plug in a 2. All right, here's where we got to be careful again, because I'm going to keep the 12. So I'm going to square the 2 and take care of that first. So that's 2 squared is positive 4. And then I've got minus 20 times 2, which is 40. So now I just need to make sure that I do 48 minus 40, which gets me back to 8, which is our final answer. So, got to be really careful with order of operations there. This one is very sneaky because I do need to square that first. Okay, we're going to do a little bit of division. So this one's going to go fairly straightforward. So f of x is 3x minus 5. G of x is 4x. All right. Not too bad, a little bit of division there. Doesn't look like I can simplify that any further, so I'm not going to worry about it. So now I just get to plug in. And this one, division really didn't help us too much because there really wasn't much to simplify, but it's okay. It's still good practice. So I'm going to put 4, and again, wherever I see an x, because again, you can kind of see that those are in the same place. I'm going to plug in a negative 3, negative 3. And then we are going to simplify as much as we can. So I see a negative 9 minus 5. You will notice I am not using a calculator for these. I am doing this without a calculator. So something to keep in mind when we practice. Negative 14, negative 12. Ooh, I'm seeing some double negatives. I also see I can simplify this by 2. So I'm going to have positive 7 over 6. Final answer, I will leave as a whole fraction. I will not use the decimals. All right, that's kind of your basic operations. So we're going to switch gears and do something called composition of functions. Composing, who would have thought that was possible in a math class? So composing is going to take the output of one function and use it as the input for the next. Biggest thing is this notation here, this open circle. That means composition of functions. So that means you need to compose them, kind of embed them within one another. Who thought you could compose in math as well as music? So the way it looks like is you're going to take all of G and put it into F. So the way that I like to do these is wherever, and I'll kind of show you here. So here's the X. Wherever I see an X. So think of F like your skeleton, like your outline. Wherever you see an X, you replace it with all of G minus 2. Okay, doesn't look like I can simplify that much, so I'm just going to bring it back together. Minus 2, and I have minus 1. All right, not too bad. All right, F of G, that's kind of how we say it, F of G of 11. So everywhere I see an X, I'm going to plug in. Again, I'm going to put my equation right here. I like to put a little bracket just so I can see. All right, positive 11 is going to go in, and then I just start simplifying. So I'm going to plug in 2. 11 minus 2, okay, that's going to be 9. And then I do see a minus 1. All right, I can do square root of 9. That's pretty straightforward. So here's a 2. And again, you'll see that I'm showing every step because this is how I can always get extra credit. And by extra credit, I mean partial credit. Probably a poor choice of words when I say extra. And final answer is 5. All done. All right, so what I'm going to do is do one more example with you guys. And it's going to be using some tables that looks just like this. So I see on the first one, I'm going to be adding f of g plus g and the number 2. So the way that I like to do that is I'm going to take f of negative 2, because this one I can't really add the functions together. So I'm just going to use the table and make it go a little faster. So it looks kind of like that. Pretty friendly, so I'm going to go over to the table and find, okay, here's negative 2. So I'm going to plug that in to f, so that one gives me a 0. Ooh, interesting. When I try to plug that into g, I get an error. Well, so that's not really going to work. So this first one, we're going to say does not exist. Does not exist. All right, that's okay. Let's try the next one. So I've got f of 2 minus g of 2. I think this is positive 2. All right, so here I'm going to look for f of positive 2. So that's right here, negative 3. Looking at the table, and then I've got g of positive 2. It's positive 1. Oh, that's a nice number, so I get negative 4. All right, looks like I get to multiply. Here's the good news, it's still 2. So I'm just going to use the numbers that I had above, make that a little bit easier. And this is a multiplication. Double check on that one just to help. See how it's a closed? So that means I'm going to be multiplying. So that one's a lot friendlier because I get positive 3. Just kidding, making sure you're still watching. All right, f of g of 3. So this one, I'm going to write f of g of 3. So the way that this is going to work with a table is going to be slightly different. So first thing I'm going to do is I'm going to locate g of 3. So here's 3. Here's g. Looks like I have a positive 2. So I'm going to leave f as the little skeleton, the outline, and I can plug in 2. All right, now I'm going to go to the f function, and I'm going to look here. I'm going to go ahead and clear out some of this so you can see all the originals as we're working. I'm going to plug in 2, which is right here, into f. So final answer is negative 3. Not too bad. All right, we're going to go backwards. So this one is g of f of negative 3. Okay, so again, this one's going to be slightly different. Let me erase my original work so you can kind of see where I'm focused on. Okay, looks like I need to plug in negative 3 into f. So here's negative 3 into f. Okay, I see I get a negative 1. So I'm going to do g. I see I get a negative 1. Okay, so now I need to go to g. Here's negative 1. Look at g. Oh, gets me 0. Final answer.